In this video, we're going to just do a few examples here of how to manipulate log expressions. In the first section of problems, we're going to be writing the equations in exponential form. And if you remember, the base raised to the power equals the answer. So we write 3 squared is equal to 9. 3 to the second power equals 9. Here we have 8 raised to the 0 power equals 1. Because a log is an exponent. It's the exponent that you have to raise the base to get to the answer. So we write 8 to the 0 equals 1. In problem 3, change that base to a 10. That's a typo. We raise the base, which is 10, to what exponent? -2. So this is what you want to be remembering. You don't want to just try to memorize where the numbers go. You want to try to memorize and understand why the numbers go where they go. So the base is always the same. Here we call this the base. Here we call this the base. Exponential form or logarithmic form. Anyway, 2 to the 10 to the -2 equals 1 over 100. And then finally, 216 to the 1/3 is equal to 6. So in this right-hand column, we have exponential form. In this column, we have logarithmic form. Well, now we're going to take the exponential form and convert to logarithmic form. So right here we have exponential form, and we know that since 5 is the base, we rewrite the log with the base of 5 of what? Well, the log base 5 of the answer, 125, equals 3, because 5 to the 3rd equals 125. So we do the same thing. We have this circular relationship between the three numbers, whether they're in exponential form or logarithmic form. So 5 to the 3rd equals 125, 5 to the 3rd equals 125. It's still circular counterclockwise. So in this case, we have a base of 27. Log base 27 of 3 is equal to 1/3, because 27 to the 1/3 equals 3. 27. Just repeat that anytime you go from exponential form to logarithmic form. Just go through it again. Make sure you wrote the numbers in the right order. 27 to the 1/3 equals 3, and you look back over here, and that's exactly what you have. All right. So now on to evaluating logarithmic expressions, which after you do a few of these, they become pretty natural, and the better you are at knowing your powers of 2, 3, 4, and whatever, the better you are going to be at doing evaluating these expressions. So for this one, we want to figure out what log base 3 of 243 is. In fact, if you remember what we talked about, a log is an exponent. It's the exponent that you have to raise the 3 to. So 3 to the what, and we'll call the what an x, equals 243. So 3 to the x equals 243. So when we solve for x, we're finding the value of the logarithmic expression. We're evaluating the expression, finding the value of it. All it is a real number that you raise the base to get to the answer. And what do we do here? What do we raise 3 to get to 243? Well, if you remember your powers of 3, 3 to the 4th is 81, 3 to the 5th is 243, therefore x is equal to 5, and therefore we want to make sure we make this very clear. The log base 3 of 243 has a value of 5. And now we do the same over here. Now this one isn't as obvious because the base is smaller than the answer, and so we just still let it equal x, and that's in fact those are the steps that we just went through right there. You set the log equal to x, and we're trying to figure out 8 raised to what power is equal to 2. So we write that exponentially. So 8 raised to some power is equal to 2, and we notice here that 8 is a power of 2, so we can rewrite 8 as 2 to the 3rd, and we can write 2 as 2 to the 1, and we remember from unit whatever that power to a power, I think it was unit 4, power to a power means you multiply it. 2 to the 3x is equal to 2 to the 1. Now here's the thing. This is very important. Pay attention. When the bases are the same and you have an exponential equation, meaning you have your variable and your exponent, if the bases are the same, that means that the exponents have to be the same. So therefore, 3x has to equal 1, And when you divide both sides by 3, you see that x is equal to, let's go up here, x is equal to 1/3, and therefore the log base 8, I really want you to do this and understand. Don't just say x equals 1/3. Say therefore log base 8 of 2 is equal to 1/3.